this tutorial we are going to do the implementation of the heap sort, which is actually using the heaps data structure. So we are solving this, we are implementing this algorithm heap sort in this tutorial. And heap sort basically sorts a given array. For example, if we have an array of integers and now we want to sort them in ascending or descending order, so our heap sort will do that. So let's see how we can implement the heap sort. So the first thing is, let's go to this main function, and I have already created this main function, and you can see that I have just initialized an array with some integer values. So we have an array with these values 12, 11, 13, 5, 7 and 6. So you can see that this array is unsorted. So this array is unsorted, and then I have created a variable n which just represents the size of our array. And then I have just called this heap sort function, and I have provided the array and the size of the array as the function arguments to the heap sort function. And finally I have just displayed the sorted array using this print array function. And you can see the print array function is very simple. We are just running a loop from the 0 position to the last position, and we are just displaying the value of the index positions from 0 to n. So this is just the print array function. So the main things that we are going to do in this tutorial is we are going to implement this heap sort function. So you can see that I have already created I've just created the prototype of this heap sort function, and in this heap sort function we are going to do some operations that will finally sort our array. So let me just first write array that we're using in this tutorial. So the values that we're going to use are 12, 11, 13, 5, 6 and 7. So this is our array, and since in the previous tutorial we have seen how we can create a heap, or we can visualize this array as a heap. So let me just convert this whole array into a heap data structure. So we know that the root of the element, the root of the heap, which is int I equals to 0, will be 12, and I will just build the heap like this. I will be 1, then 2, then I equals to 3 will be stored here, which is 5, then 6 will be stored here, and finally 7. So I've used the 3 formulas which we have discussed in the previous tutorial to build this heap. So this is a heap, but you can see that this is not following the max heap property or the min heap property. This is only a heap. So we have discussed about the max heap property and the min heap property, and in the heap sort function we are going to use the max heap property to sort our array. So let me just convert this heap into a max heap. So we know that the max heapify property says that the key of any particular node should be greater than or equal to the parent key's node. So I will write it like this. So when we will convert this heap into a max heap, so we are converting it into a max heap. We are just using our knowledge of the previous tutorial in this max heap property. So after converting this max heap, our heap will look like this. 13 will come here, then 11, then 12, and then 5, 6, and then 7. So this is what our max heap, or the Heapify function, I should say, the max Heapify function will do. So the first task of in the heap sort function is to rearrange the given array into a max heap. So we are going to call this Heapify function, or the max Heapify function. We will just call this function, which will just convert our given array into this max heap. So you can see that after the call of this Heapify function, we will obtain the largest element at the root of our nearly complete binary tree. And you can see that in this whole array, 13 is the largest element. So after the Heapify function, after we will just call this Heapify function, and we will call this recursively. So this Heapify function is a recursive function. It calls itself by providing some other values, and it will just swap the values if they are not following the max heap property, which says this. So the child's key should be greater than the parent's key. The child's key should be less than equal to the parent's key. This is the max Heapify property. So you can see that after every call, or after calling this Heapify function, you will obtain a heap which has the root element as the largest element. And that is the main reason why we use max heaps in priority queues. So we use max heap in priority queues because if we want to obtain, or if we want to get any element which has the highest priority, we can just call this Heapify function, and we will just obtain the largest element with the largest value, or the largest key, and we can just use the property queues as the implementation of the heap. So now what we are going to do is we are going to see how the Heapify function should be called. So first thing is that the Heapify function should not be used to heapify or to max heapify the leaf nodes. And we know the leaf nodes are the last nodes which does not have any children. So you can see that these nodes are not having any children, so these are the leaf nodes. So we'll have to take care that the Heapify function is not called on the leaf nodes. For that, we are going to run our for loop from I equals to n by 2 minus 1, and this will run till 0, and after every iteration we are just going to decrease the value of I. So let's suppose in this example, in this particular example, we know that the value of n is equals to 6. So the value of I in the first iteration will be equal to 6 by 2 minus 1, which evaluates to be 2. So in this for loop, first the value of I will be 2, in the next iteration it will be 1, and then it will be 0. So by this you can see that we will call the Heapify function on the index values 2, 1 and 0 position. So you can see that by using this whole strategy, we are just ignoring the leaf nodes, and we will just call the Heapify function or the max Heapify function, and we will provide it the array, the size of the array, and the index position at which it should start its heapifying or max heapifying operation. So this for loop is important. Its logic should be clear that we are running this for loop from n by 2 minus 1 till 0, and every time we are decrementing the value of I by 1, and this is just to ignore these leaf nodes, which you can see by seeing these values of I. So let's now implement the max Heapify function, we are just calling it as Heapify. So in the max Heapify function, in the heap sort function, we will just create a for loop, and this for loop will run from I equals to n by 2 minus 1, and I should be greater than equal to 0. It should be int I, and after every iteration we are just going to decrement the value of I by 1, and this for loop will just heapify. We will call the Heapify function here, and we will provide the array and the size of the array and the index position from where it should start its heapifying. So this Heapify function will go from I equals to 2 and then 1 and 0, and it will perform the heapifying, and it will just ignore the leaf nodes. So let's look at our Heapify function. So the main strategy that we're going to use to heapify or to max heapify our tree is we are just going to assign the root element of our this binary tree as the largest element. We know that it is not the largest, but we are considering the first element of the array as the largest element. So in the Heapify function, I will just assign, I will create a variable largest, and I will just assign it as the value of I. So we are just initializing the largest variable as the root. Initialize largest as root. So let's suppose we are calling this max Heapify function when I is equals to 2. So the largest will point to this value. So if you will call the Heapify function on this array which has some size n, and the I will represent at the index position where we are going to use this Heapify function. So let's suppose the value of I equals to 2. So we are going to consider only this subtree. In this subtree, the root node is 13, and so we are going to assign the largest element as 13. We can even take any other value, but it will go from 2, so we will initialize it as the largest. So luckily we can see here that this is also the largest element of our array, but if we take some other example, this will not be the case always. So we are not just taking it as largest because we know that it is the largest, but we are taking it as largest. We are just assuming it to be largest. At this point, we do not know whether it is the largest in this given array or not. We can obtain the largest element only after this Heapify function will be performed on all the subtrees. So let's call this Heapify function on this subtree. We will first assign the first element as the largest. To get the left and the right children, we have this formula. So let's write the left as L. To get the left child, we know that we will just use this formula 2 into I plus 1, and this will give us the left child of the subtree where we are going to perform the Heapify function. To get the right subtree, we are going to use this formula, and we have discussed these two formulas in the previous tutorial. So this is the right child. So you can see that now we have the largest element of the subtree, where we are going to perform this heapify function, and we also have the left and the right child. So the next thing is we are going to write the check statements. So first of all, we will check if the left child is greater than the root element. So we know that since we are creating a max heapify function, we know that the root node should has, or you can say the child should has a value less than the root. So we are just going to create a if statement, and we know that the left child, so if the rule is violated, if the max heap property rule is violated, so this means that the value at the left child and is greater than the value of left is greater than the largest value, which is the root element of the subtree. And one more thing to note here is that the index position of left should not be greater than the size of the array. It should be less than. It cannot be even equal to the n, because we are ignoring the leaf nodes. So if the rule is violated, if the left child is having the greater value than the root, or you should say than the parent, so we are just going to assign the largest variable as the child. And similarly, if the right child is greater than the root, so I will write another if statement here, which says that if the value at the right value of the right child is greater than the value of the parent. And one more thing to note here is that the right child should be less than the size of the array. And if this rule is violated, we are just going to assign the left, we are going to assign the largest node as the right. So you can see here that I have assigned the largest node as right. So let's see how this whole code is going to run. So first of all, I'm just going to take this subtree 13 and then 7. This is the subtree that we are considering, and we know that initially the value of I was equal to 2. So according to this code, it says we are going to assign this root as the largest element, and we know that this is the left child, and we know that there is no right child. So if the value of right child is greater than n, we know that n is 6, so we are not going to heapify that, because right child is not available at that moment. So now let's take this left child, and we are going to run this if loop, which says that if the value of the left child is greater than the value of the root child, which is also the largest element. So if this rule is violated, then what we are going to do is we are going to assign largest as this one. But you can see that 7 is not greater than 13. So we know that 7 is not greater than 13. So the largest will remain here. It is not going to change. So let's suppose I will take this subtree, which is 12, 11 and 13. So if we take this subtree, then we know that the value of I will be equal to 0. So when the value of I will become equal to 0, then the heapify function will perform this heapifying at this whole subtree. So it will call it recursively, and we will also have to just write the recursive function, which we have not done yet. We are just comparing the values at this moment. So we know that this is the largest value, which is equals to I. So we will compare it with the left and the right child. First we have compared it with the left child, and after comparing you can see that the value of the left child is less than the largest value, so the rule is not violated, so the largest value will not change. But if you see this right child, you can observe that the rule is violated here. The value of the right child is greater than the largest value, so we are going to assign the right child as the largest. So now largest will be equal to R, which you can see here. We are doing that. So when we will change the value of largest, then after changing that we will have to do a swap function. So if the value of largest has changed, that means the value is now not equal to I, because now if the value of largest has changed, it is not I, it is either right value or it is pointing to the left child. So we are running this loop, and when this condition is true, we are just going to swap. We will call this inbuilt swap function, which is used to swap the positions. So we will have to swap the largest value and the value at the ith position. So this is how we are going to swap. So you can see here that if the largest has changed, then we are just going to swap the value at the largest position with this. So after swapping, this will become 12 and this will become 13. So you see that after swapping this value, this subtree, which is you can see that we have swapped these two values, so this is 13 and this is now 12. So you can see that now this subtree has been affected. So that means that we will have to call the Heapify function again on this one, on this subtree, because this value has changed now. So it might be violating this max Heapify rule again. So we will have to use recursion to if the value of the largest has changed, we will have to call this Heapify function again on this subtree. So we are going to call, so I'm writing a comment here that we are going to recursively heapify the affected, I should say, subtree. So after swapping the values, we can see that the subtree has been affected. So we will have to again call the Heapify function to avoid any mistake. So now we will call the Heapify function again, and we will provide the array and the size, and now this time we are not going to give it the value which we are passing. Now we are going to give it the value of the largest. So if the value of the largest variable is now pointing to left child or the right child, then what we are just going to do is, if the value has changed, then we have swapped the two values, and after swapping, now we are calling the Heapify function from this largest position, which might be right child or the left child. So this is how our Heapify function will look like. So let's suppose we have called this Heapify function when I is equals to 0. So we have seen that we need to swap these two values. So this will become 13 and this will become 12. And after swapping, we can see that this subtree has been affected. The value has been changed. And we know that the largest value is pointing to the right child. So we are again going to call the Heapify function on this subtree by providing it the position, the largest position. And this Heapify function will again work in the same manner. It will again check this if condition and it will do this recursively. So Heapify function is a recursive function. It is indeed a recursive function, and thus the complexity, the time complexity is log of n. So let's run the program and see how our array will look like after calling all the Heapify functions. So let's run this whole program. So now you can see that the array is now, it looks like this. You can see that after calling the Heapify function, the array is not sorted, but the largest element is at the top. So what I'm just going to do here is, I am going to write this, I'm going to visualize this array as a heap, and let's see whether this heap is actually working properly or not. And by working properly, I mean that whether it is following the max heap property or not, because we have written these conditions, these two conditions, to check whether, to ensure that it should follow the max heap property. So let's visualize this as a max heap and see, as a heap, and see whether the heap obtained is a max heap or not. So the result was 13, then 11, then 12, then 5, 6 and 7. So after calling the Heapify function, we have obtained this array. So let's visualize it as a nearly complete binary tree. So root element will be 13, which is I equals to 0. Then 11 will come here, then 12, then 5, and then 6, and then the last one is the 7. So you can see here that this indeed is a max heap. So this is a max heap, and you can see that the largest element of this array can be found at the root position, which is I equals to 0. So this property is very useful. It can be used in priority queues, and we are going to use this property of max heap to sort our array. You can see that this array is not sorted. We will have to do some more rearrangements and some swappings to ensure that this array is sorted. So we will sort this array in the ascending order like this. So I'm going to write here a very important point, that a max heap will just give the largest element at the root position, which is I equals to 0. So we are going to use this important property to sort our given array. So let's see what we will do to heap sort. So we have seen the first step in heap sort is to max heapify the given heap. And the second step is what we are now going to do, and the second step is the actual sorting. And we are going to use this max heap property to sort our array. Let's see how. So we know that the max heap property will give the largest element at the root position. One important thing to note about max heap is that we can obtain a sorted array in the ascending order using the max heap property. So the simple idea is to just put this root element at the last position of the given array. So what we are going to do is we are going to swap this value 13, which is the largest value of our array, with the last position. So I'm going to write some positions here. So we will swap the root element with the end of the element, and when we do this, you can see that after swapping these two values, we will obtain a result like this: 7, 11, 12, 13, 5, and then 6. And I'm going to write the positions here. So you can see that after you will just move this first element to the root of the node, you will get the largest element at the last position of the array, which is needed here. You can see that to sort our given array, we will have to push the largest element in this array at the last position. So we will swap these two positions. The next step is to notice that after swapping, this tree is no more a heap. You can see that after swapping, this 7 is now violating the rule. If we are just going to ignore the first element and we are going to now notice this tree, so we will run a loop which will run from I equals to n minus 1 position till 0, and we are just going to swap the first value with the last value after every iteration. So you can see that after every iteration we will obtain the largest element of the subarray and we will just ignore this value by decrementing the value of I. And now you can see that after swapping the values, this is no more a heap. So now what we are going to do is we are going to call the Heapify function. We will call the Heapify function at the root node and it will just heapify this whole array. But remember, you will have to ignore this last value. The main reason is that because if you will call the Heapify function on this whole array without ignoring this element will get again pushed up at the top, which we do not need. So we are going to use this for loop which will run from I equals to n minus 1 till 0, and after every loop we are just going to ignore the values, which is 5, then we will ignore 6, and after each iteration we are going to perform this Heapify function on this array, on the subarray. And we know that if we will perform the Heapify function on the subarray, we will get the largest element at the top. So let's just consider this whole array or this whole subtree, or I should say this tree. This is not a subtree, this is a whole tree. So what is the largest element in this subtree? So 12 is the largest element. So the Heapify function will be called at the root position and it will just swap these two values, and we know that Heapify function will just max heapify the given tree and it will just bring up the largest element at the top. So now 12 will come at the top position. So now you can see that 12 will come at this position and 7 will come at this position. So when we will do this again and again, now 12 will be swapped with the last value of the array, and so the 6 will get changed to 12. So what we are doing, the basic idea is we are using the max heap property and we are just swapping the root value, which is the maximum value, with the last index position, and after every iteration we are just ignoring the last value, and we are calling this Heapify function again and again, and which will just push the element with the largest value at the root position, and then we will again just swap it with the last element of this array, and in this manner we will just go iteratively, and then we will obtain a sorted array. So let's now implement this the step 2 now. So in step 2 we are going to the heap sort function, and the first thing that we are going to do is we are going to run a for loop which will run from int I equals to n minus 1 position, and the value of I should be greater than 0, greater than equal to 0, and after each iteration I will just decrement the value of I to ignore the last element after each iteration. So what we are just doing is, in this step we are just obtaining elements one by one. So one by one extraction of elements from heap. So we will call this for loop, and it will run from the n minus 1 position, and it will run from till 0. So the first thing that we are going to do in each iteration is to swap, and we are going to swap the root position, which is the 0th position of the array, and we are going to swap it with the last element, which is at the ith position. So this is how we are going to swap. We will swap the root element or the first element of the array with the last element, because I equals to n minus 1, and we will do this swapping again and again. But remember that after every swap we will have to perform the Heapify function, which will bring up the largest element of the array at the top position. So I'm going to provide array, the size of the array, and the size of the array should be I, and we are going to perform the Heapify function on this index position 0. So Heapify function will always will perform this heapify, this max heapifying at the root position. So that's why we are giving it the position 0, and we are giving this value I because we want to change this array. We are going to decrement it by 1 so that it will ignore the last element, which you can see here. We will have to ignore this last element after each iteration, and in this manner we are using the max heap property to sort our given array. So it is a little bit confusing, but if you will just run this program on your own, and if you will see how this actually works, you can take an example of your own. You can change these values, and then you can also see the working of this whole program, and you can observe how after each iteration how the program is working and how Heapify function is running. So let's now run this program that we have written, and let's see if the array is sorted in the ascending order or not. So after running, you can see now that the array is now sorted in the ascending order. So if you have used the min heap, you will get a sorted array in the descending order. So you will have to take care of these two steps. These are the most important steps. This function will just heapify, it will just build a max heap. So I'm going to write here, it just builds a max heap, and this step is used to actually sort the element, and it is sorting by extracting the elements and after extracting we are just swapping the values, and after swap we will just call the Heapify function. But remember that the Heapify function will be called at the root position, and after each iteration the Heapify function should ignore the last value. So that's why we are running it from ith position. So you can see that now the left child and the right child will be always less than n, and n is the ith position which we are passing at this point. So this is how our heap sort function will look like. So thanks for watching.